Hi everyone, welcome to CodeTav Management. Today we will solve today's Geeks for Geeks problem of the day, which is vertex cover. The question is like vertex cover of an undirected graph is a list of vertices such that every vertex not in the vertex cover share their every edge with the vertices in the vertex cover. In other words, for every edge in the graph, at least one of the endpoints of the graph should belong to the vertex cover. So you will be given an undirected graph G, and your task is to determine the smallest possible size of a vertex cover. So here the n is 5, m is 6. So edges are like 1, 2, 4, 1, 2, 4, 3, 4, 5, 2, 1, 3. So here 6 edges are there, right? So here output is 3 because 2, 3, 4 forms a vertex cover with the smallest size. Okay. So next is like in 2m1, then edges here like 1, comma 2. So only included either node 1 or node 2. Okay. So these are there. So here expected time complexity is this one and space complexity of big of n square. Okay, so I will just discuss about my solution. So here, what we have done is like the class solution is already there, and after that, this vertex cover method is there that takes the three parameters. One is n, m, and edges, and it returns an integer. The method is designed to calculate a vertex cover for a given graph. So after that, we are initializing the variable as answer to integer max value. So this variable will be used to store the minimum vertex cover size. And after that, we have made one label, which is the outer loop. So this is basically used to create a labeled loop for breaking out of nested loops. So then after that, we have started one for loop that iterates from 0 to 2 to the power n, means exclusive, and where n is the number of vertices uh, in the graph, and this loop is used to iterate over all the possible combinations of vertices in the graph. And after that, another for loop is there. So this loop basically starts another loop that iterates over the edges of the graph, and then we are checking one conditions, so you can see properly. Just a minute. Okay, so here the line that checks if the current combination of the vertices I, okay, it covers the current edge, which is edge is j, and it uses the bitwise operations to check if either the endpoint of the edge is included in the current combination or not. And after that, if the condition is not met, the loop labeled outer loop is continued, and effectively keeping the next combination of the vertices. So then we are here the code calculates the number of set bits in the current combination of vertices I using that integer dot bit count, and updates the answer variable with the minimum count so far. And finally, we are just returning the answer, which will return the minimum vertex cover size found during the iterations. So this is our approach. You can also comment down your approach as well, and just do practicing, and do like, share, subscribe. Thank you, everyone.